Hello, my name is Jordan, and I'll be going over the questions of the practice final exam. Question 1 is to find the volume of the solid generated by revolving the region bounded by curves f of x equals square root of x and g of x equals x squared. Sorry about that. About y equals 1. First, we'll sketch the graph, and since we're rotating about y equals 1, we'll make a very long y-axis, and we'll graph g of x in blue. X squared is an upward-facing parabola. It'll look something like that. Let me redraw that. Square root of x is kind of the opposite, more right side facing, but it'll look like this. And they both connect at this point right here, which is 1, with a y-axis of 1. And this will be y equals 1, the line that we're rotating about. And when we rotate it, it'll look something like this. And since we're revolving, here's the 3D aspect. Alright, here's a graph, and now to find the volume of this, we need to divide the graph into a bunch of equally width-sized rectangles and compute the area of each of those. So let's draw a rectangle on both sides since it's being revolved. And now we're just revolving the rectangle. You can see we're getting this washer shape. That'll be important for later. And this is the area that we need to find the equation of so that we can find the volume of the entire region. So now we need to find our limits, which can be set by setting these curves equal to each other. And we'll skip a step by subtracting square root of x from each side. And we can pull out an x to the 1/2. And that'll give us an x to the 3/2 minus 1. And this gives us x equals 0 and 1. Next, we will be using the washer method. To do that, we need to find an inner radius and an outer radius. So that would be big R and little r. All right. So we need to find the radius of these. And we can see from here to here, it's going to be 1 since we rotated from y equals 1. And we can just see that that would be 1 minus x squared. And the rest would be 1 minus square root of x. So, big R would be 1 minus x squared, and little r would be 1 minus square root of x. The washer formula has the formula a of x is equal to pi times big R squared minus R squared. And we can solve for R squared, for big R and little r squared. When we FOIL, we'll get 1 minus 2x squared plus x to the fourth, and 1 minus 2 root x plus x. Then we'll take r squared minus little r squared, and in order from highest power to lowest power, we'll get x to the fourth minus 2x squared minus x plus 2 root x. So now we can plug r squared minus r squared into here. And we would get pi times this value. Now to solve for the volume, all we have to do is write the volume is equal to, we'll pull out this coefficient from the integral, and this integral is from 0 to 1, like we found before, and then it'll just be these values in respect to x. And we'll go ahead and integrate. So it'd be pi times x to the fifth over 5 minus 2 x to the third over 3 minus x to the 2 over 2 plus 2 x to the 3 halves over 3 halves, evaluated from 0 to 1. X to the 3 halves over 3 halves is the same as multiplying both sides by 2/3, and that would give us 4x to the 3 halves over 3. And we can see if we plug in 0 to any of these x values, we'll get 0. So we'll skip that step and only plug in the 1, which would give us 1/5 minus 2/3 minus 1/2 plus 4/3. The common denominator is 30, so we'll have pi times 6 over 30. I'll write it all over 30, minus 20 over 30, minus 15 over 30, plus 40 over 30. When we add all of that together, we will have 6 minus 20 minus 15 plus 40, which gives us 11 over 30 pi. That is the volume of this solid rotated about the line y equals 1. The next question is to find the volume of the surface area formed by rotating the graph of the curve y equals x squared from x equals 0 to x equals square root of 2 along the y-axis. Like before, we'll start off by graphing. Since we're rotating along the y-axis, I'll leave a lot of room for that. and we are only given x squared. Again, x squared is an upward facing parabola. So this will be 0, and we'll say this is square root of 2. Next, it needs to be rotated along the y-axis. So we'll get something like that. This would be negative root 2. And we'll show the 3D aspect of it just to prove it's been rotated. So, since we're rotating in terms of y, and since we're rotating about the y-axis, and we're trying to find the surface area, that means we are going to get the equation y equals x squared in terms of x. So that is equal to x equals square root of y. And since these limits were in terms of x, we need to get them in terms of y to find our new limits. So when we plug 0 into x, we get a value for a, which is equal to 0. And when we plug root 2 into x, we get a value of 2. So there are our new limits. Next, we will plug our information into the surface area formula. You can find out surface area by multiplying 2 pi times the integral from 0 to 2 times root y coming from here. And we need to take one more step because in here is 1 plus x, derivative of x cubed, squared, I'm sorry, dy. So the derivative of x is 1 over 2 root y. And we can go ahead and square it too. Derivative of x squared would be 1 over 4y. We can also notice that this is a square root and this is a square root, and they're multiplying each other. So we can distribute this y value into both of these terms. So we would get 2 pi times the integral from 0 to 2, y times 1 is just y, plus y times 1 over 4y is just 1 over 4. This is all under a square root, dy. Next we can use u substitution, where u is equal to y plus 1 over 4, and du would be equal to dy. And we can also go ahead and change our limits. When we plug 0 into this equation for y, we would get 0 plus 1/4. So u is equal to 1/4. And when we plug in 2, u would be equal to 2 plus 1/4, which is 9/4. So we'd have 2 pi from the integral of 1/4 to 9/4 times, we replaced y plus 1/4 with u, so u to the 1/2 du. And this is a very easy integral. So it's going to be 2 pi times u to the 1/2 is 2/3 u to the 3/2. And that's being integrated from 1/4 to 9/4. And we can go ahead and evaluate this, which would be 2 pi times 9/4 square rooted is 3/2. 3/2 to the cubed is 27 over 8. And 27 times this 2/3 is 9 over 4. Then we can do minus 1/4 squared is 1/2. 1/2 cubed is 1/8. Taking out that 2, it's back to 1/4. And multiplying by the leftover 3 is 1/12. And to make our life easier, we can go ahead and take out this 2, making this a 2 and this a 6. So the common denominator for 9/2 minus 1/6 is 6. So we'll have pi times 9 times 3 is 27 over 6 minus 1 over 6, which is equal to 26 pi over 6, which is equal to 13 pi over 3. That's question 2, and that is the volume of the surface area of the graph y equals x squared from x equals 0 to x equals square root of 2. Next, we'll do question 3. Question 3 asks us to find the center of the mass of the, that's supposed to be lamina of uniform density with rho equals 1, bounded by the graph of f of x equals 4 minus x squared and the x-axis. First, we can graph our f of x, and that's just a downwards facing parabola because of the negative symbol. And since there's a positive 4, we'll start at 4, and it's just downwards. So we want to find the center of mass of this graph. First, we need to find the limits. So we can just set 0 equal to 4 minus x squared, and we just solve for x. X would be equal to plus or minus 2, which would relate to these x values. Now we need to find the mass, my, and mx. So step 3, mass is equal to density times area. We know the density is 1, so we can say mass is equal to area. To find the area of this, which would be this, all we have to do is take the integral from -2 to 2 of the function, which was 4 minus x squared dx. And this is 4x minus x cubed over 3, evaluated from -2 to 2. And then we can just plug in our values. And we would have 4 times 2 is 8, minus 8 over 3, minus negative 8 plus 8 over 3. Since a negative and a negative make a positive, we can say this is equal to 16 minus 16 over 3. And that is equal to 32 over 3. So we found our mass. Now we need to find my, and my is equal to rho times 2 times the integral of negative 2 to 2 times x times the function, which is f minus x squared dx. That is equal to, we can distribute the x value, and we know this rho is 1. So this is equal to the integral from negative 2 to 2 for x minus x cubed dx. And that is 4x squared over 2. We can simplify this to 2x squared minus x to the 4th over 4, evaluated from negative 2 to 2. This is equal to 8 minus 4 minus 8 minus 4. And this is equal to 0. Next we need to find mx. Mx is equal to rho times the integral from negative 2 to 2 times 1/2, so we can pull out the 1/2 of 4 minus x squared squared dx. And we can go ahead and FOIL. And since we know rho is 1, we can say 1/2 times the integral from negative 2 to 2 of 16 minus 8x squared plus x to the 4th dx. And we can go ahead and integrate that. That would be 16x minus 8x cubed over 3 plus x to the 5th over 5, evaluated from negative 2 to 2. And we can go ahead and evaluate that. That'd be 32 minus 64 over 3 plus 32 over 5 minus negative 32 plus 64 over 3 minus 32 over 5. We can do some simplifying. 64 minus 128 over 3 plus 64 over 5. We can do some more simplifying. This would be 512 over 15. That would be equal to 512 over 30, which can be simplified one more time for 256 over 15. Next, we need to find x bar and y bar. So step D, x bar is equal to my over m. My is 0 over 32 over 3, and that is equal to 0. Y bar is equal to mx over m. Mx is 256 over 15, and m is 32 over 3. And once we divide that, we would get 768 over 480, which is equal to 8/5. So, our center of mass has the coordinates 0, 8/5. On the graph, that would be maybe about there. The next question is the integral of x to the 5th sine 2x dx. We can solve this using the tabular method, where we will start with a positive. We'll write down our u value, which would be x to the 5th, and we'll write down our dv value, which would be sine of 2x. Next, we can take the derivative of x to the 5th, and we can keep taking that derivative until we reach 0. So we get 5x to the 4th, then we get 20th x to the 3rd, and we get 60 x to the 2nd, and we get 120 x, and we get 120, then we'd get 0. Then we can take the antiderivative of sine of 2x until we reach the same position. So we'd get negative cosine of 2x over 2. Then we'd get negative sine of 2x over 4. And we get cosine of 2x over 8. Then we would get sine of 2x over 16. And we get negative cosine of 2x over 32. And we'd get negative sine of 2x over 64. And we have our sign changes right here, and those would just alternate on the side. Next, we match up these items, and here comes the easy part. We just write it down. So, the integral of x to the 5th times sine of 2x dx is equal to negative x to the 5th cosine of 2x over 2 plus 5x to the 4th sine of 2x over 4 plus 20x to the cubed times cosine of 2x over 8 minus 60x squared times sine of 2x over 16 minus 120x times cosine of 2x over 32 plus 120 sine of 2x over 64 and plus c. That was questions 1 through 4.